Hi there, my name is Dr. Marissa May. In this video, we're going to look at some operations with radical expressions. So let's look at the first one. We're subtracting these two radicals, but I want you to focus in on the numbers underneath the radical symbol. Notice they are not the same number. When this happens, you can't actually subtract them. So we'll work with getting one of them to simplify. And just a hint, usually the bigger number is the one that you can simplify. So I'm going to come over to the side and let's think about 63. And I'm going to do what's called a factor tree. I'm looking for terms that multiply to give me 63. So since it's a 6 and a 3, I'm going to use 3 and 21. Now, you may be thinking, well, why didn't she use 7 and 9? I easily could have. I like to deal with small numbers first. So this 3 being a prime number, I'm going to circle it just to help me remember that it is prime and that branch of the factor tree is actually finished. Then I'm going to work on 21. That is 3 and 7. 3 times 7. And again, those are both prime numbers, so I know that part of the factor tree is finished. So notice that we have 63 is really 3 times 3 times 7. When we're simplifying radicals, we're looking for a pair. So you see this pair of 3's here. I'm going to actually rewrite the square root of 63 as a pair of 3's. Notice I only wrote it one time on the outside of a radical with a 7 underneath. And the 7 is underneath because the 7 did not have a pair to simplify with. Now, I want you to look then at the subtraction. Now your radicals have the same number underneath them, and you're going to be able to subtract. So 1 square root of 7 minus 3 square roots of 7 would give me negative 2 square roots of 7. Okay, let's look at number 2 then here. Rationalize the denominator. Now, when we are dealing with radicals, we generally do not like to have a radical in the denominator. So what we do is we do something called rationalizing the denominator. Let me show you what happens. So since I have the radical of a fraction, I'm going to rewrite that as a fraction with two radicals. I'm just going to split them up so that I can easily see the radical that's in the denominator. And now to rationalize the denominator, I'm going to multiply the top and the bottom by the radical that's in the denominator. Let me show you what happens, and I think you'll see why I did that. So on top, let's multiply what's under the radical. 7 times 3x would give me 21x. And on the bottom, I would get 3 times 3 is 9. X times x is x to the second. Now, 9x to the second then would simplify to just 3x without a radical. So the whole purpose of rationalizing the denominator is to get the radical out of the denominator. So what we do is we multiply the top and the bottom by that radical in the denominator so that it will go away.